Welcome, everyone. It's just after lunch, and I appreciate you being here to see this talk. My name is Michael Coburn. I'm a consultant with Percona. Tomorrow, actually, I'm going to be celebrating 3 years with the company. I've titled this one, Running MySQL on AWS, and what we're going to try to focus on are some of the basic details of what AWS is all about. I'm going to go through some of the acronyms so that we all have a common understanding of what we're getting into. And then towards the end, I'm going to focus on some of the very different tuning options you want to consider when you're working in a virtualized environment. And then hopefully we'll have a little bit of time at the end to go through a Q&A. Okay? So, I moved to Costa Rica a little while ago, but fortunately Percona's got customers all across the world. Doesn't matter where you live. And so I'm really happy to be back here in the States, but I'm also really eager to get back home. The other thing is that in my afternoons, I work on the Percona on-call team. So that means that I get to see environments all over the place in terms of the best and some of the worst. And I've been doing this for probably about 6 months now, where I spend my afternoons doing this kind of work. So, 10 different environments a week is not uncommon. And I'm going to say it's not really a quotable number that I like to put, but whatever, 50% are on AWS. Rackspace does exist, HP Cloud to a certain degree, but by and large, AWS is where the business is happening right now. Okay, so if you guys are thinking about AWS as your deployment platform, you can't really go wrong with that. Okay, there's going to be a lot of acronyms. I want to just get that out of the way. If you have any questions, I'm really happy just to have you lift up your hand, and I'll call out, and we'll get it addressed right away. Okay, let's see here. AWS stands for Amazon Web Services. Okay, it's their product that they're monetizing what they were using to support the Amazon.com infrastructure. Okay, they needed a vehicle to be able to spin up new application servers and databases, et cetera, to run their main product website. And then they went, oh my gosh, we can actually sell this thing to other people. And now it's turned into its own, I think last numbers they reported were about $2 billion a year in revenue and going on like a 50% year over year kind of growth. So in terms of revenue generation for Amazon, it's not as big as the bookseller retailer side, but it's a behemoth in its own regard. And it's clearly the dominant player in terms of the virtualized market out there. But through talks that I've had with some other their competitors, I mean, there's Microsoft with their Azure platform. They've got bottomless money pits. I haven't seen Apple make any moves to it. Maybe they will. As we know, they've got lots of money. And Google as well. Those guys have a piggy bank that has no bottom to it as well. And they're pushing hard on it. The Google Compute platform, and they're probably going to come out with an RDS similar kind of product. Okay, so the field is wide, but right now, Amazon is where it's at. Okay, virtualization. You need to make a decision, and maybe you've already done that, is to say, well, do I want to run my application or my server, my database on a physical box or on a virtualized box? Well, what the heck does that mean? It's a very straightforward concept that means that you take this physical server, and on top of it, you can run one or maybe more instances of an operating system. And you treat those operating systems as if they're a physical server. So you don't even need to really realize or be aware that it's a virtualized or non-virtualized platform. You still install MySQL, you install Apache, you do everything normal in there. But there are some trade-offs, okay? And I'm going to talk about what some of those differences are. One of the common deployment tools or platforms that we see is the Linux environment. You can deploy Windows in there, you can deploy Solaris and other flavors, but for the purposes of this talk and for the purposes of my own experience working with customers, Linux is the 99.9% of deployed operating system within Amazon Web Services. Okay, it's what Percona is developing on for Percona Server. It's what Oracle is releasing primarily for. There is more tuning in MySQL for Linux. Certainly, you can go to Oracle's site and download Mac versions, OS X versions, and Windows versions, and Solaris builds of MySQL. And your mileage may vary. Certainly, they'll run, but they're probably not as optimally built as you'll find for the Linux platform. Okay, EC2. There are two main variants of where you're going to be able to run MySQL. The first is this one. EC2 stands for Elastic Cloud Compute. Fancy description for saying this is the main virtualized environment. This is where you go, hey, I got some money. I want to run maybe 2 or 3 MySQL servers. I need 3 instances of EC2. Okay, and what that really means is you just spin up this image, this disk image, and now suddenly you've got a way to SSH in and do some installations of MySQL, copy some data in, and start using it like a database. Okay. There are a couple different hypervisors, which is the difference between a physical server and a virtualized one. The hypervisor is this little abstraction layer between the guest, which is what we're talking about, the virtualized instance, and the physical underlying server. So there's a bit of a performance penalty that you pay, and that's where the hypervisor comes into play. Amazon allows you two different, I believe it's called para-virtualized versus, starts with an H. HVM. Thank you very much. Thank you very much. So they both have their pros and cons. I'm not going to get into splitting hairs on it, but they're both available to you, and I don't believe there's a cost difference to either of them. Okay. You can stipulate larger or smaller instance sizes. This is akin to saying, well, what should my buffer pool size be? I don't know. It depends on your workload. You may say, well, I'm just starting out my website. I've got no data, and it's probably going to be half a year until I've got 10 gigs in there. My advice to you would probably be start small. Go get one of the micros. Go get one of the medium-sized instances that have maybe 8 gigs of RAM. That helps you keep your costs down low. And the advantage to this model is that if you buy small today, that means that next month, next year, you can easily scale this up. You just go ahead and buy another larger instance, and it's available to you within 30 seconds to maybe 5 minutes. That's how long it takes to spin up a new instance. Compare that to the old model of running this in a physical environment, where it becomes maybe call your purchasing department, or even just call up your CDW rep or whoever you buy hardware. Wait a few weeks to get the RAM shipped, take the downtime, load the RAM in. It's a different way of provisioning equipment in the EC2 model. Question? I'm not sure with the RAM sizing if you can do that in place. I know with things like the disk you can. Thank you. Thank you.
I guess when you start, you have to look there also. If you don't want to migrate, you go for lower and for the same instance classes.
That's one way to see it. The other model could be is that don't be too intimidated about doing a migration. Get comfortable with the concepts of MySQL replication. Use it early so that you're comfortable saying, oh, I need to fail my application from one server to another. And as soon as you're comfortable doing that, then that server you're failing to becomes a larger instance size, and you promote it to master. So it's a concept that is very flexible. MySQL replication is awesome and gets you out of a lot of problems. Okay. So the concept here is that you go from these little guys, these little 1 gig instance sizes, all the way up to now I think you can get about 240 gigs in an instance. And what that really means is you're probably buying the only virtualized machine running on that one single server. So you're effectively buying a server from Amazon and paying them monthly for that. It's going to cost you a lot, probably to the tune of a few thousand a month. But a lot of applications need that. And hopefully at that point you're making lots of money, so it's not that big of a deal. You pay hourly, that's right. Okay, EBS. This is probably where you're going to put your data. Okay, this is detached storage. This is network-based storage, but from the purposes and the views and the usage of it, you're going to treat it like it's locally attached. Some of you might be familiar with things like NFS or distributed file systems or Samba or any of these other file sharing protocols. This is kind of what they're doing. It's a little hybrid of their own. You don't need to worry about that. All you see is a little block device that you format and you mount and you put MySQL there. So the point is EBS stands for Elastic Block Storage. And what it allows you to do is to grow the disk that MySQL is running on and the capacity of that disk independently from the instance. So the old model is I got my server running in my data center. Oh, I want to make the drives go faster. I want to upgrade from 10K to 15K spinning drives. Well, hopefully you've got space to put new drives in. If you don't, you're going to have to take downtime, copy the data, swap drives. Very complicated. In this case, in a lot of places, you can just kind of tune a knob and things get faster or larger for you. You have to do little things within Linux, but in a lot of cases, it can be a no downtime kind of option. So it's really cool when you say, hey, it's Black Friday coming up and I'm a retailer and maybe the week before we're going to go and we know we're going to double our site traffic, so my database is going to get pounded. Well, that's a great play for you to say, hey, look, boss, we're going to double our provisioned IOPS for a little while. Make sure that there's capacity there to sustain the new activity that's going to come in. Black Friday comes and goes. You look like a hero. You can turn that knob back down. So you're paying basically on an hourly basis for the resources that you need. It's a great platform. Okay. RDS, and I'm sorry, I'm skipping a couple points because I just got the 10-minute warning. The RDS platform is the black box of database. It's the database as a service. You're probably hearing it a little bit here at the conference. What it basically means is that Amazon is spinning up MySQL instances on your behalf and automating some parts of it. They're taking care of the backups for you. You're saying, oh, I want to have some slave hung off of this. In the old model in EC2 or the physical thing, you have to go and take the backup, copy the backup, set up replication. Not anymore. RDS takes care of all of that for you. They take their own snapshots in the back end. They stand up these servers in different geographical locations for you if you need it. It's awesome, super awesome. If you want to go further and spend the right money on it, you can do multi-AZ failover for the master. And that's just fancy way of saying, hey, look, if your master goes down, they've got a methodology of saying, I'm going to make sure the master comes up somewhere else in the world, and they're going to fix everything else. The slaves will find the new master, and your website will experience some measure of downtime, but only in the order of like 15 or 30 seconds kind of downtime. So the advantage of using RDS is a tremendous one. You give up some things. You don't have as much control over the environment. But on the flip side, maybe that's something that you want. If you're not a DBA and you just say, well, I'm an app developer and I just need a database, RDS is the way to go. Okay? I have this slide about IOPS. I just want to be clear that IOPS stand for the input-output operations that your database is doing with the disks. It's a very critical number. For every query that you do, it usually involves some measure of talking to the disk. It's either going to read data because it's not in the buffer, or it needs to write out data because it's being consistent with the data set. So that's going to come at a cost. It's going to get to some threshold number, and at some point you're going to say, geez, the database won't go any faster. I need to get more IOPS. Amazon's found a way to commoditize that, and they're going to charge you for buying more of it. But again, busier database hopefully means more revenue coming into your company, so it shouldn't be that big of a trade-off. Okay. What I like about EC2, I'm a consultant first and foremost, but I have also been in your shoes as an actual embedded DBA with a company. I like EC2 better because I get more visibility out of it. There's just more, I'm running in the environment, in the Linux environment. I have a shell. I can do GDB. I can do OProfile. I can check the disks, what they're doing, all that sort of stuff. It's a little bit cheaper. Depending on the instance sizes, it could be about half as cheap as RDS. Maybe it's probably closer to about 75% as cheap. Excuse me. RDS, like I said earlier, it's the black box. It's the magic. It's the secret sauce. The downside is, again, you don't have that shell access. It's a little harder to recover if there's a corruption or a crash condition. You're counting on Amazon's back-end magic, again, to save you in some regards. They're going to do their own automated crash recovery. If that fails, though, your only alternative is to go back to the most recent snapshot backup that the environment's taken for you. That may not be great because those snapshots aren't happening every second. They're happening every configurable, but every day at least. So you could lose up to a day's worth of data, and that may be something that you want to protect against. Okay. Why, though? Why do we take a step back here and think about why is AWS important in general? The developers love it. DevOps guys love it. DBAs are coming to love it. Developers love it because it's so simple to spin up new environments. DevOps guys love it because they can spin up and destroy environments very quickly, and then they can start treating this old physical hardware as if it's application code. And that's a really great play. That's why Chef and Puppet and Ansible are all these really popular technologies for managing their environment. Okay, you get a command line interfaces. You get API ways, so that means you can put your own pretty interfaces on managing your EC2 environment and your RDS environments. And there's also companies out there that are trying to put these dashboards out that you can pay and use and leverage their tools to make working with AWS a little bit easier. Okay. I probably should have had this slide earlier. The difference between the virtualized and the non-virtualized. The reason you might say, well, look, maybe a question would come up. I went and I used AWS, and it just didn't work for my application. The most common reason I'll hear that is you're going to tell me that I need every bit of performance I can get out of my work or out of my database that I'm buying. I want to make sure I've got the lowest latency when I talk to the drives. I want to make sure that nobody else, no other application, can impact the performance of my database. And the reason those two things can come up, the first one about the raw access to the block device, to the drive, means that there's no hypervisor in between. You're talking over a very fast backplane and a physical server, and that's as fast as it's going to get. That's as good as it's going to get. There's no network latency between your virtualized instance and AWS talking to the virtualized disk in EBS. Okay, so physical gets you the fast drives. On the other side, virtualized environments probably means you're sharing that server with somebody else. Now, they do a good piece of work in the hypervisor to make sure that their work doesn't affect your work, but it sometimes still happens. So you might find that through no fault of your own, your database got a little bit slower for some measurable period of time. Somebody else on your EC2 instance could have been taking away resources from you. Just be thinking about these things. It's not always going to be your fault in a virtualized environment when things get slow. Okay. I think we covered this. I just got the 5-minute as well, so I want to make sure I save some time for questions here too. I want to compare and contrast really quickly. EC2, you get a lot more options because you've got the file level access. You can use extra backup. This is probably your first default you should be thinking about doing, Percona extra backup to take your backups. But you can still use MySQL dump, which is a command line client to dump out a logical version of your backups. Or you can use LVM or EBS snapshots to take a backup of your database. EBS snapshots obviously only work if you're using EBS. On RDS, you're a little more limited. You've got MySQL dump and RDS snapshots. There's also another one I didn't list, which is MyDumper, but it's kind of a play on MySQL dump. It's a parallelized MySQL dump routine. When you need to change the configuration, you've got access through VI or Emacs to the config file in EC2, and you've got the MySQL client to connect in and change a global variable if you need to. On the RDS side, you still kind of have that. It's called parameter group, but the drawback is there's less things. Yes, there's less things in RDS that you can actually change. You'll get in there and you'll see that something's configured to some value, but it's going to have a flag that says is modifiable false or off or something like that. And you just can't modify it. And sometimes, in some cases, you're going to say, that really hurts me. I wish I could change that. For the longest time, our big example was the InterDB log file size was not modifiable in RDS. A few weeks ago, they changed that, but that was a pain point. If you had a write-heavy workload, being unable to change the log file size was a huge deterrent to using RDS. So the good news is I actually met last night a developer, a manager from Amazon RDS, and he was looking for my feedback, and he was also very receptive to what I had indicated both through this talk and a couple other ones, but my concerns about RDS, and they're looking to improve. They're constantly looking to make that environment better. So I feel a lot better being up here today saying, well, look, I used to have reservations about RDS, but these guys are on top of it and trying to make it better every day. How do you upgrade? Well, you're going to use your native tools in EC2. You're going to treat it like Linux, like you do every day, yum or apt-get or whatever it is that you need to do. Then you're going to run MySQL upgrade after it. It's on you, though. It's manual. You do it on your schedule when you're ready to do it through your maintenance window. In RDS, they've got predefined maintenance windows, and they're going to patch it for you. Well, if you're treating it like a black box, you probably don't want to know the nitty-gritty about doing upgrades. You probably want to know what it's going to look like to operate in the new environment, but you don't need to know how to do the upgrade. Let Amazon do it for you. And in RDS, automatic. How do you bring up a new slave? I touched on this earlier. In EC2, it's on you. You got to copy the data. You have to move it around. You got to start it up. Hopefully nothing got corrupted in between. Get the right change master statement. It's not impossible. People do it all day long, but it is a few steps. In RDS, it's a few clicks or it's a few API calls to set up read replicas. It's dead simple, and they work like a champ. They're fantastic. They're sized as large as your RDS instances. I'm not sure if there's a price point difference. I've never actually looked at that to see if they're cheaper or not to have RDS read replicas out there. How do you fail over? This is kind of a neat trick, and this is something that I work a lot with customers on, both in EC2 or physical hardware. They're saying, well, hey, look, what do I do if my East Coast goes down? How do I survive? Well, there's tools out there that help you fail over your application between MySQL servers. And then those tools then tie in with, okay, great, you failed me over from Virginia over to California, but now what do I do? Well, I have to point my app to talk to California. Okay, well, what about all the slaves I had out there? My master that was in Virginia just failed. I need to tell them all about how to find the new guy out there in California. Well, these two tools I mentioned, MHA and PRM, they have those kinds of functionality and features built into them to get you up to speed in an EC2 or a physical environment to repoint these slaves over, okay? In RDS, like I talked earlier, you've got the multi-AZ failover. All of this stuff is handled for you. At some level, you still need to tell your your application of where the new databases are, but that's the extent of your work. That's your developer side that generally has to take care of that. All the machinations over change master statements and figuring out who's furthest ahead in promotions, RDS takes care of that for you, okay? Very much a hands-off kind of thing. This one's really straightforward. You want to add a column or an index. It's identical in both methods. You're going to use probably PT Online Schema Change from Percona Toolkit or Alter Table. Either one of them work, and you're going to do it the same way in both environments. 2 more slides. Monitoring the health of MySQL. In EC2, you've probably got a little more flexibility. You can run something like our Percona Cloud Tools, which has an agent which runs in the EC2 environment and talks to the database and gets the OS level metrics and gets the slow query log, which is written out in an EC2 environment. Or you can use the Cacti or the Zabbix or the Xenos or whatever it is your environment likes to use. In RDS, you can still kind of hack it to have Percona Cloud Tools working, but you don't get the OS level stuff, nor do you get the slow query log, because in RDS, that stuff is abstracted. You don't get access to it. Excuse me. Now, I shouldn't say, I'm not trying to make this too negative, because you do get some pretty graphs through CloudWatch in EC2, in RDS. So you're not kind of left out there, but you have to look in a few places to find metrics over what's happening within your RDS environment. Okay, how do you recover? Well, again, from a consultant side, I typically see customers when they're in trouble, when they're having an emergency, and that makes it a lot easier if I can get raw access to the disks and to see the operating system and to read logs and figure out what went wrong so I know what to fix. That's why I like EC2 better. You get all that stuff. I can run things like forced recovery. I can use my data recovery toolkit. If your database is completely corrupted, won't even start, I can probably recover something out of that for you. In RDS, it's not there, right? We can't change forced recovery. We're hoping that RDS developers have figured out a way to do that for you after it's tried to restart a few times. Maybe it's incrementing up this variable or some magic, some secret sauce. But the point is it's opaque. You don't know what they're doing, and you're just crossing your fingers that it's going to recover for you. If it doesn't recover, you're going to do a snapshot. You're going to get your database back up, but it's going to be older, and you're going to have missed some data. And that's unfortunate. Okay, just some high-level points. Careful with AWS. It's so easy to spin up instances, RDS or EC2 or what have you, that sometimes you forget to turn them off. And Amazon's okay with that because they're going to charge you for it. So don't leave them sitting around. Because you can very easily move to more instances, don't feel like you need to deploy today the solution that you think you're going to need in 18 months. You do need to do that if you're buying physical gear, but you don't need to do that in these virtualized environments. So go a little bit smaller. Plan a 6-month horizon instead of the 18-month horizon. Okay? Use and abuse EBS snapshots. They're really cheap in terms of cost and in terms of impact to your app to get them. Use them. They will save you. Automate it. I see some nodding heads. Good. And the last thing, if you're in RDS, go ahead. It's the first option when you're configuring the environment. It's defaulted to on for multi-AZ deployment. Take it. It's going to cost you a bit more, but whatever. It's totally worth it. It's your get-out-of-jail-free card. I mean, if you're just doing like a little dev test environment, maybe it's not worth it. But if this is prod, use multi-AZ. Take advantage of the tools that Amazon's giving you to make sure your app sustains outages, because they're not infallible. They have power outages too, as much as they like to say that they won't, but their SLA is not 100%. Their service level agreement is not rock solid. They are going to have outages, and you will feel it at some point over the career that you work with them. So use their tools to protect yourself from those kinds of outages. Okay, so that's the bulk of my presentation. I want to open it up to any questions, anything I might have missed or I can cover more completely. Anything?
How the Percona, the PCT, Percona Cloud Tools work with RDS? How do you install the agent on RDS? There's no shell. You only have the MySQL connection. So how do you install the agent?
Question is, that's a good question. How do you make Percona Cloud Tools work with RDS? Because you can't, normally the agent needs to run in the same environment as the database server. And that's why I called it a hack. What you do is you configure an EC2 instance that is in the same VPC as your RDS box, so it has network connectivity to it. And then you run the agent there, and when you configure it, you go into the GUI interface within the Percona Cloud Tools deployment, and you say, don't check the local host for the database server. Use the TCP socket to connect to the RDS instance.
Okay,
So
like a bridge, you can have a micro instance as a bridge.
exactly, a micro instance would be a perfect play right there. You don't get the slow logs, right? Because the slow logs are only available in RDS or through an API call, and we haven't written any code yet to suck that out, parse it, and submit to the platform. So it's not a full solution yet. Any other questions? Go ahead. Yes, RDS. The question is, does RDS have a master and slave? It does. That is a good question. The question is, what is the default bin log format for an RDS master? I want to say mixed. I know it's not statement. Anybody know for sure? Let's go with mixed. Because in one of my other talks, when I talked about a challenge I had migrating a customer into RDS, I ran into a problem with PT table sync, which is a tool that we do to reconcile a slave to its master. It tries to force the slave, in this case it was RDS was a slave, into bin log format equals statement. It wouldn't let it do it. First, because it wasn't in, you don't have super in RDS. But the second thing was, it was clearly not already in statement. Otherwise, the check wouldn't have fired. So, and so the concept or the naming nomenclature is that RDS is the primary master, and then everything else is a read replica. Now, the slaves are the read replicas. Okay. And did you have a question? Go ahead.
Can you tell a little bit about the pricing model? I imagine that network traffic probably is important, or what else is included? And question number 2, how easy is it to get a huge bill unexpectedly?
Okay, question is, first, a little bit about the pricing model, and a second is it unexpected to get a huge bill? I'll answer the second one first. It is very easy to get an unexpected huge bill. So easy. We worked with a customer of ours where we weren't deleting their S3 backups, and 3 months later, they got a $70,000 bill when they usually get about $5,000 a month. So, oops. So that kind of stuff happens all the time, right? So you got to be careful. You got to be vigilant. But around the pricing, I don't work for Amazon. I mean, I don't even know to what extent Percona has a relationship. If we do even have one, it's not very deep. The point is that you can price your things so split up. You can price it based on how much network throughput you need, plus the instance size, plus the disk capacity, plus the throughput of the drives. All these little nuggets add up. So to make it simpler, Amazon has has a cost calculator that covers all of their products. You put in your expected usage, you put in the requirements you have and the count of instances, and you get a nice number of what they estimate you're gonna need. Okay. One thing to keep in mind is that traffic generally between AWS tools is free. So between your EC2 and your RDS, that doesn't cost you anything. Through the load balancers, nothing. Through S3, I don't think it costs anything. And then in and out of the data centers, that's where they're going to start biting you a little bit. Okay. Any other questions?
Could you talk a little bit? We came in late, so we'll just look at the slides here.
Sure.
Could you talk a little bit about performance? Is there performance difference having your stuff on the cloud?
Yeah. So the question is, so I'm going to answer that in regards to comparing the two AWS platforms. Is there a performance difference between them? And yes, there actually is. Again, I don't work for Amazon. I don't know the back end. I don't have any of the secret insight on. All I know is when I do my own benchmarks, I've seen RDS be about 3 to 4 milliseconds slower when I use a synthetic benchmark like Sysbench. I truly don't know where those are coming from, because when I've talked with these guys with their little head nods, sometimes I think that all this is running EC2 in the back end, is what an RDS instance is. But, I mean, nobody's confirmed that for me. So I would have always thought that they should be fairly equivalent. So maybe there's some overhead regards to hops between your EC2 instance where you might be running your application server till it gets to the back end. Okay, so basically RDS is a different platform, probably on a whole different host of servers. Therefore, the latency accrues as you try to communicate with those platforms. So if you're looking for raw performance and you're going to stay in AWS, EC2 is going to be marginally faster. Okay, I just got I should end my talk. Are there any other questions? Okay, that's it. Thank you, everybody.